Hi, we're going to work on stoichiometry gram to mole. We're going to need our periodic tables and you will need a calculator. First question, how many grams of carbon dioxide or CO2 can you make if you start with 4.9 moles of C4H10? We have our equation listed out down here and it is balanced. So we're going to start off by drawing a little road map for this equation. I'm going to use a line and put in first what we have. So we currently have 4.9 moles of C4H10. We are trying to get grams of CO2. So we know that our first box is going to contain 4.9 mole of C4H10. Draw a line here. Nothing will go underneath this line. We need to make a mole ratio to happen in this in these two boxes. I'll create two boxes here, but we have to use what is given in our question. So we have 4.9 moles of C4H10. We have to find C4H10. It's right here. We are getting our carbon dioxide, which is right here. So what we need to do for our mole ratio is first cancel out our 4.9 moles of C4H10 by putting it in this box to the bottom right. And it's going to be divided by the balanced equation molarity. You will notice that our coefficient for C4H10 is 2, and our coefficient for carbon dioxide, or CO2, is 8. That coefficient is how many moles are in that molecule. So I'm going to go ahead and put 2 moles of C4H10 here. And above it, I'm going to have 8 moles of carbon dioxide. We can draw another box here. Okay. Lastly, we need to cancel out this mole of carbon dioxide, and notice that in this bottom right box, we have to divide by a mole there as well. So we are going to have 1 mole of CO2 there. Now, the part that takes a little time is we actually need to find the molar mass of the molecule of carbon dioxide. So I'm going to flip over to our periodic table here. In our periodic table, we need to find carbon and we need to find oxygen. They're both nonmetals, so they're going to be over here at this staircase. Our AMU is 12.01 for carbon. Our oxygen is 16. What we can do is actually, this program I'm using has a pretty nifty calculator that we can use. So there are 12.01 grams in, I'll make this a little bigger, put at 48. 12.01 grams in carbon, and there are 16 grams in oxygen. But also notice that we need to multiply that by 2 because it's carbon dioxide. There's 2 oxygens. When we press equals, we see that we get a 44.01 gram of CO2. So we are going to write this out here. So we are 100% CO2, and we are finding grams of that. So we have 44.01. We can switch back to our chart here. 44.01 grams of CO2. Notice we are successful because the question is asking for grams of CO2 and we're ending this in grams of CO2. Also notice, and I won't go over this in all the problems, but I will underline, actually I'll just highlight here. This is moles of C4H10. This is moles of C4H10. We will also see here that this is moles of CO2. This is moles of CO2. So our product that we're getting is going to be grams, because these two are going to cancel out mole and mole, and these two are going to cancel out mole and mole of the respective molecule. We can now use our in-service calculator here. Again, I'm going to need to blow this up, but I'll type it out first. 4.9. And let's make this 48. Make it a little bigger. 4.9 times 8 times 44.01 divided by, and I always put my divisions in parentheses in case I have more to divide by, but we do not. So we actually end up with 862.596 grams, and I'll just write this out here, of CO2. Although this is a larger 2, I could use the math insert, but what I will show you is that it's actually this, and we have a subscript there of CO2. Okay. All right, next problem. Our balance equation is up here. How many moles of aluminum chloride can you make if you start with 14.58 grams of hydrochloric acid, or HCl? We're going to do the same thing by starting off with a line, just to help us navigate how we're going to multiply and divide this. We're also going to go to our highlighter, and we're starting off with 14.5 grams of hydrochloric acid, and we are trying to transfer that or find the moles of aluminum chloride. So we're starting off with these grams of hydrochloric acid. Let's fill that in. So we start off with 14.58 grams of hydrochloric acid. Put our division there. Nothing goes here. Okay. We need to get our mole ratio. But the problem here is that we're starting with grams, so we actually need to find out how many grams are in 1 mole of hydrochloric acid. Okay. So we're going to try to find out how many moles of hydrochloric acid. So we need to use our periodic table right away for this question. So let's pop on over HCl. We can easily erase this. Boom. Boom, boom. And we're going to highlight where HCl is. So we're going to find hydrogen right here. We have a mass of 1.01, and we need chlorine 35.5. Notice that we didn't have any subscripts, so that's going to be exact. We don't need to multiply by anything. So we're trying to find HCl. We're trying to find the grams of HCl here. I'm going to go ahead and use the same box. Looks like it went away. The same box. So we have 1.01 plus 35.5. I'll blow this up here. Boom. To a nice 48. And we can simply press equals. We get 36.51 grams of HCl. So we're going to put that right here. 36.51 grams of HCl. Okay, now we have how many, this will eliminate each other, and now we can actually go into our mole ratio. So if we look back up here, our mole ratio, where we have AlCl3, so we have to find that AlCl3 right up here. Actually, I'll use the appropriate highlighter for that. We used green. And we also have hydrochloric acid. And that is right here, 6. The 6 and the 2 for the 6 HCl and the 2 AlCl3 is the coefficient. That is also the molarity, as we were talking about. So we need to eliminate this mole, this 1 mole of HCl. So we have to put the ratio down here. So we have 6 moles of HCl for every 2 moles of AlCl3. Boom. Okay. So Now all we need to do is, because we're ending off with what the question is asking for, moles of aluminum chloride, and we're ending it with that. So we have to multiply the top, divide by the bottom. I will start typing this in right here. So we have 14.58. Again, make this bigger. 14.58 times 2, we don't need to multiply by 1, divided by parentheses 36.51 times 6 on parentheses equals, and we end up with 0.01331, and that's going to be moles of AlCl3. Again, with the appropriate subscript, it will be moles of AlCl3. Okay, next question. Here's our equation. Here's our question. Let's highlight right away. We are trying to find how many grams of H2O. So we're trying to find grams of H2O can we make if you start with 16.9 moles of O2. So this is what we're going to start with, what's highlighted in green, 16.9 moles of O2, or oxygen gas. So let's draw our line. We start off with 16.9 moles of O2. Draw our vertical line. Nothing goes here. Whatever we have or whatever we start with, we always put top left. We need to cancel out this moles using mole ratio. So we need to refer to our balanced equation up top here. O2, looks like we have 11 moles of O2. And we have H2O, we have 8 moles of H2O. Perfect. So we're going to put the moles of H2O on top because that's what we're trying to find. So 8 moles of H2O for every 11 moles of oxygen gas, or O2. The last thing we need to do is cancel out these moles of H2O. And we're going to do that by finding out in 1 mole of H2O how many grams of H2O there are. And notice yet again, these moles of O2, moles of O2. So those are going to cancel out. We also have moles of H2O, moles of H2O. Those are going to cancel out, and we're going to be left with our grams of H2O. So we got to go back to our periodic table and find out how many grams are in H2O. So I'll erase what we have here and erase what we have highlighted, and we'll re-highlight. We have 1H. Okay, so we're back to highlighting this, 1.01, and we have O. H2O, I'll erase this current equation, I'll leave the 1 there. H2O, we have 2 H's, and we have 1 O. Well, if that's the case, we have 1.01 times 2, because we have 2 H's, plus 16. And we get 18.02. Let's go back here. 18.02 is what we're ending with. We can simply multiply the top and divide by the bottom now. 16.9. Pulling this back up. 16.9 times 8 times 18.02 divided by 11. We get 221.4822. We're not doing scientific rounding here. And we are going to end up with grams of H2O, or with the appropriate subscript, H2O. Great. Next question. Our equations listed on top. And we're going to work with what we are being asked. How many moles of water, H2O, can you make if you start with 147.2 grams of oxygen gas? Let's highlight what we have. We have 147 grams of oxygen gas. We are trying to find moles of water. Let's go ahead and make our line here. And we're going to put 147.2 grams of O2 up here. Make our line. Nothing goes down here. We need to transfer or exchange this grams for how many are in 1 mole of O2. 1 mole of O2 consists of how many grams of O2? Now, we understood from our periodic table, I can actually just flip here. Oxygen has 16. We're just multiplying that by 2, and that's going to be 32. 32 grams of O2. Okay. Now we can do our mole ratio. We need to utilize our balanced equation on top here. So we have O2, which I'll highlight in yellow. We have 5 moles of O2. We also see that we have water. We have 4 moles of water. So we want to end up with that water. So we have 4 moles of H2O for every 5 moles of oxygen gas. Notice again, if we want to check our work, grams of O2, grams of O2. We also have moles of O2 here, moles of O2 here. That's good. Okay, we want to cancel out. The bottom right always cancels out the top left to find the very top right box. Now we can calculate. We'll move down here, start a box, start typing 147.2, make it bigger, 48, stretch it out. Okay, and we are going to multiply that. We don't need to multiply it by 1, so we're going to multiply it by 4, and that's going to be divided by utilize parentheses, or else that 32, this 32, if we just do divided by 32, maybe I'll just show you what happens when we do it without the parentheses. 32 times 5 equals 92. Now watch what happens when I put parentheses around this. It looks like it did the same thing. So some calculators will have the order of operations occur. It will take this multiplication and divide it by this 32. And I'll double check this on my calculator just to make sure that we are getting the same answer here. So 147.2 times 4 divided by 32 times 5. And I actually get 3.68 on my calculator. So let's erase this line to see what it gets. Yep. So order of operations. So let's try that again. If we don't have our parentheses here, and I think this calculates it after you delete the answer and press enter. Yeah. So it's 2 separate answers here. So you always want to put those parentheses in if you're just going to finish your problem. There we go. 3.68. Just a good habit to form, especially if you're test taking really quick. So we have 3.68, and that is going to be moles of H2O. And again, expand this H2O. And again, to have the correct subscript here, this will be, I'll get white back here, H2O. Okay. Our next question and last question. Our equation on top with the question, how many moles of sulfur can you make if you start with 306.8 grams of hydrogen sulfide? Let's highlight what we have. So we have 306.8 grams of hydrogen sulfide. We have to find moles of sulfur. I'm going to go ahead and start our line again. Looks like it didn't click appropriately. Here we go. Start our line again. And we start with 306.8 grams of H2S or hydrogen sulfide. Nothing goes down here. we need to transfer this gram into moles. So we're going to put moles on top, 1 mole that is, of H2S. And we have to use our periodic table to find out how many grams are in H2S. So we're going to flip over to our periodic table, erase all this madness. We're going to put H2S to know what we're finding on top. We're going to delete or erase our work there and also erase our equation there. I'll leave that one just so I know where it's at. Let's highlight where H is. So we see we have 1.01 of hydrogen, and we find our sulfur over here, a nonmetal, 32.1. Notice we do have 2 H's, so I'm going to put that in the equation here. We're going to start typing this out. So we have 1.01 for our hydrogen, but we have to multiply that by 2. We are then going to add, and due to order of operations, that multiplication will occur first. We add our sulfur next, and we can put equal here. We get 34.12, and that will be of grams of H2S, or hydrogen sulfide. 34.12. 34.12 goes here, grams of hydrogen sulfide. Okay, last step. We got to do our mole ratio. We have our mole of H2S up here, so we also have to put it down here. Okay, our ratio, we'll find our H2S. We found it right here. It's at the start of our equation. We have 8 moles of H2S that I highlighted in yellow in the equation, and in green we find our sulfur, which we don't have any moles there. If no moles or coefficients are listed in front of that particular molecule or atom, it is just 1. So we're going to go ahead and put 1 mole S8 here, and that is for every 8 moles of hydrogen sulfide. Now we can do our equation, or rather our math for this. Click here. I'm going to start off with 306.8, and I'm going to blow this up so we can see it. Okay. And let's make this happen. So 306.8, we don't need to multiply by 1, and we don't need to multiply by 1 yet again. So we can just start our division. 306.8 divided by, remember our parentheses because we're dividing by more than one number, 34.12 grams of hydrogen sulfide multiplied by 8 moles of hydrogen sulfide. And we need to get the parentheses there as well. We end up with 1.124, and I'm going to go ahead and write moles of sulfur. And that is it.